Hello, T-Rex math students. Today we have two goals in this video. The first one being that we need to review adding and subtracting fractions with positive and negatives. And the second goal being multiplying and dividing fractions with positive and negatives. I chose these because there were a couple questions on the test that many missed that involved those two learning targets. Thinking back to what students struggled on, there was a problem where you had to add 3/4 plus -1/2, and that would be an addition problem involving fractions with a negative and a positive. And there was another problem where you had to multiply numbers such as 5/7 multiplied by 1/3. And let's say that was a -5/7. So in that situation, there is a different set of rules that go for multiplication and division versus addition and subtraction. Let's look at more detail at the addition and subtraction of fractions with unlike denominators. So since the two denominators that are being compared are 4 and 2, you want to find a multiple that both 4 and 2 have in common. So if I count by 4s or count by 2s, what will both 4 and 2 share? So I actually only need to keep 3/4 as 3/4 because I know that 2 groups of 2 gives us 4. If I multiply the denominator by a factor of 2, I have to multiply the numerator by a factor of 2, which will give me a -2. Then I add. So when I'm adding those, I can even think of 3 minus 2, or 3/4 minus 2/4, or I can think of 3 plus a -2 as a 3/4 plus a -2/4. Those each would simplify to 1/4 or 1/4. Denominators stay the same when adding and subtracting. So let's take another one like that. If I look at the denominators in this case, I have a 5 and a 3. So if I count by 5s and I count by 3s, I get a common denominator of 15. So if I rewrite 2/5, I could think of 5 groups of 3 is 15, so 2 groups of 3 is 6/15 plus how many groups of 3 is 15? 5 groups of 3 is 15, so 5 groups of -1 is -5. If I simplify that, I might think of 6 minus 5, which is 1/15, or if I look at it like on the left, 6 plus a -5 is 1, and the denominator stays the same. In the case of multiplication, you do not need common denominators. So I could take this multiplication problem, like the one on the test, and rewrite it as 1 multiplied by -5 over 3 multiplied by 7, and not worry at all about the denominators. So if I go 1 multiplied by -5, I get a product of -5. 3 multiplied by 7, I get a product of -5 over 21. So if I look at -5 over 21 and I check it, it is simplified because you cannot divide -5 or 21 by the same factor. So my answer is -5 over 21. Let's take another example. Say I have -2/5 and I'm multiplying it by 1/2. So if I look at that, I again don't need common denominators when I'm multiplying. I can multiply the two numerators above the product of the two denominators, and I get -2 times 1, which is -2, and 5 times 2, which is 10. So -2/10 you can try and simplify. So I can divide -2 by 2 and get -1. And I could divide 10 by 2 and get positive 5. So negative 1/5 is the product. Whether you recall it or not, you learned what the reciprocal is in 6th grade. If I take a division problem, let's say 2/5, and I want to divide it by 1/3, I'm trying to figure out how many 1/3s fit into 2/5. So in order to do that, I can rewrite it as a multiplication problem by keeping the first term exactly the same. Trying to highlight there, but finding the reciprocal of the second term. So in this case, 1/3 would have a reciprocal of 3/1, basically turning that fraction upside down. Then I replace my division sign with a multiplication sign. Notice I did not do anything with the first fraction. So from here, I treat this exactly like I would a multiplication problem. I multiply 2 by 3 to get 6, and 5 multiplied by 1 to get 5. So 6/5 is 2/5 divided by 1/3. 6/5 can also be written as 1 and 1/5. Let's check that out one more time. Let's say this time we take a negative 1/5 and we're going to divide it by 2/3. So again, we're trying to figure out how many groups of 2/3 can fit into negative 1/5. Well, because we have a negative and a positive being divided, we know that our quotient is going to be negative. So I'm going to write that up there. We have one negative and one positive, and whenever multiplying and dividing, one of each sign is going to be a negative. So let's turn this into a multiplication problem by taking the first term and leaving it alone, and making the second term, the divisor, into its reciprocal by turning the fraction upside down, and then changing the division sign into a multiplication sign. Then we treat that as we would multiplication. Negative 1 multiplied by 3 above 5 multiplied by 2. So if I simplify that, I get negative 3 over 10. So your next steps today are to take what you learned and recall from adding fractions, subtracting fractions, multiplying fractions, and dividing fractions, all with negative and positive rational numbers, and practice. So I've assigned 2 pages that you can practice these, and these are linked in Schoology along with an answer key so you can check how things are going. Do the best you can, and may you have a great rest of the day. Thanks, T-Rex math students.